Hello students, this is lecture number 3 on transportation and game theory. In this video lecture, we are going to discuss about Vogel's approximation method. So concept covered in this lecture are, we first explain what is Vogel approximation method, and after that we will discuss some examples based on Vogel's approximation method. Vogel's approximation method is for finding optimal solution or near to optimal solution. This method is better than, that is Vogel's approximation method is better than northwest corner method and least cost method. This method gives us better initial basic feasible solution as compared to northwest corner method and least cost method. So we prefer Vogel's approximation method as compared to northwest corner method or least cost method to find the optimal solution. So we will discuss the various steps how we can solve transportation problem by using Vogel's approximation method. So first step is, for each row of the table means the transportation problem that we have given. So for each row of the table, identify the lowest and the next lowest cost cell. Find their difference and place it to the right of that row. If two cells contain the same least cost, then difference shall be 0. The difference is known as unit penalty. जो हम difference find करेंगे, least cost and the next minimum and the next minimum, जो difference हमें मिलेगा, उस difference को हम क्या बोलेंगे? That is the unit penalty. Now step number 2. Similarly, find the difference of each column. Each column means we find the minimum cost of first column and the next minimum of that particular column, and then we find the difference between them. This gives us the unit penalty of that particular column. Similarly, we find the difference of each column and then place it below each column. Step number 3. Choose the row or column with largest unit penalty. जिसमें जिस रो या कॉलम में हमें पेनल्टी सबसे मैक्सिमम मिलेगी, ज्यादा मिलेगी, we choose that particular row or column. Allocate the maximum possible unit to the least cost cell. Then we try to allocate the maximum possible units to that least cost cell, जिसमें हमें जो per unit cost होगा, that is the minimum. Least cost cell in the selected row or column, so that either demand or supply is exhausted. In case of tie, in selecting largest unit penalty, if there is a tie, then what we do? Choose row or column with minimum cost. If there is again a tie in minimum cost, select the row or column where maximum allocation can be made. Now step number 4, adjust the supply and demand and cross the satisfied row or column. If row supply or column demand both are exhausted, eliminate both the rows and column. Step 5, recompute the column or row difference, ignoring deleted row, column, and go to step number 3. Repeat the procedure until all column and rows total are satisfied. So this is the method. Sometimes this question asked in the examination, explain Vogel's approximation method in detail. So you can write all the 5 steps to write your answer. Okay. Now this is the example. Now we will discuss the example problem related to transportation problem by using Vogel's approximation method. So P, Q, R, S, these are the destination point. A, B, C, they are the sources. Supply is 500, 300, 200. Demand is 180, 150, 350, 200, 320. Sum of demand is 1000. Sum of supply is 1000. So it is a balanced problem. Now, if the problem is balanced, then what we do? We calculate the penalty. We denote this penalty P1. Penalty, how we can calculate penalty? The row minimum is 10, the next minimum is 12, 12. So we can take any one of them. So what is the difference between 10 and 12? So penalty is 2. 12 minus 10, it is 2. Now come to this row. Minimum is 7, next minimum is 8. The penalty is 8 minus 7, 1. Minimum is 6, next minimum is 7. Penalty is 1. Now come to column. Minimum is 6, next minimum is 7, so penalty is 1. In this column, minimum is 10, next minimum is 11, penalty is 1. Here penalty is 8, 11 minus 8, 3. Here penalty is 7 and 13, so 13 minus 7, it is 6. So we find the maximum penalty. Out of these penalty, 6 is the maximum. So we can choose this because this gives the maximum penalty. So what we do, we find the minimum cost cell. So this 7 is the minimum cost cell. So what we do, we try to send as many as possible number of item in this station, in this point. So supply is 200, demand is 320, so we can send 200 items. So this row is exhausted. So we can put cross, we can make a line in this row because this row is exhausted. And 320, 200 demand is fulfilled. So we have left with 120. Demand is 120 now. Now again we calculate the penalty P2 because this row again we get penalties 2. This we get 1. We put dash here because this cell is exhausted. This row is exhausted. Now calculate penalty P2 from column. Again we get 1. No, we get 7 minus 12. It is 5. 10 minus 10 and 11. 10 is the minimum. 11 is the next minimum. So 1. 8 and 12. So we get 4. Because and this 13 and 14. So we get 1. Now 5 is the maximum. So because 5, 1, 4, 1, 1, 2. 5 is the maximum penalty, so we can choose this maximum penalty. Now come to this column. What is the minimum? 7 is the minimum. So we try to allocate maximum number of item in this point. So demand is 180, supply is 300, so we can allocate 180 items. By allocating 180 item, this cell is exhausted, so we can put line in this column and we left with 120 item in this station. Now again we calculate penalty P3. What is P3? Now 10 is the minimum, 12 is the next minimum, so penalty is 2. 8 is the minimum, 11 is the next minimum, penalty is 3. This cell is exhausted. Now come to P3. Because this first column is exhausted, so we can put dash. Second penalty is 1. Next penalty is 4. Next penalty is 1. So what is maximum? Yes, 4 is maximum. So we can choose this because this gives us the maximum penalty. So what is the minimum? 8 is minimum. So our focus is to send maximum number of item in this point. Because we have only 120 item in supply and 350 is demand, so we can send 120 item. By sending 120 item, this cell is exhausted. So we can cross this and we have 230 items left in this station. Now we have only one row, so there is no need to calculate penalty. Right? So we can assign 150 is demand, so we can assign 150 item at this point. So we get 350. Now 12 is minimum, so we assign 230 item in this point. This cell is over, so we can cancel out. We get 120, and now we can assign 120 at this point. So the transportation problem is complete. So the number of rows are 4. So if we take m is the number of rows, then number of rows is 3, n is number of column is 4. Therefore, number of allocations are m plus n minus 1, that is equal to 3 plus 4 minus 1, that is 6. So for basic feasible solution, we need 6 allocation. Here we can see that 1, 2, 3, 4, 5, 6. There are 6 allocation. So this gives us the basic feasible. Even we get the initial basic feasible solution. And this problem is non-degenerated. So now we can calculate the transportation cost. How we can calculate? We multiply the transportation number of allocation with the per unit cost. 180 into 7, 150 into 10, 230 into 12, 120 into 13, 200 into 7. And after calculating this, we get the transportation cost is rupees 9,440. Now let us discuss one more example. This is the transportation problem. We have to solve this problem by Vogel's approximation method. So 40, 60, 50 is the supply point, 20, 30, 50, 50 is the demand. Total sum is 150. Sum and total supply is equal to total demand. So it is a balance problem. Now, by Vogel's approximation method, we calculate the penalty. In this case, penalty is 2, 0, because 6 and 6 both are minimum. So 6 minus 6, it is 0. 6, 7, so penalty is 1. Now come to column. Penalty is 4 minus 6 minus 4, 2. It is 1. It is 0 and 1. So we get penalty 2 is maximum. And there is a tie in penalty. So we calculate which gives the minimum, because it is common. This 4 is common to this 2 as well as this 2. So we choose any one of them. So let us choose this one. So if we choose this, then we can assign 20 items to this point. After assigning 20 items, this column is exhausted and we are left with 20 items. Now we will calculate penalty P2. 6 is minimum, 8 is next minimum, so difference is 2. 6 is minimum, 7 is next minimum, difference is 1. 6 is minimum, 7 is next minimum, difference is 1. Now column wise, because this cell is exhausted, we can put dash. 6 minus 7, it is 1. 6 minus 6, it is 0. 7 minus 8, it is 1. So now we get maximum is 2. So this is maximum. So we can choose this one because 6 is minimum. The cost 6 is minimum. So we can assign maximum number of items in this point. So 20 is supplied, 30 is demand. So we can assign 20 items. After assigning 20 items, this cell is exhausted and this demand for this station is 10 items. Now again we calculate penalty P3. Because this cell is exhausted, row is exhausted, so we can put dash. Now come to this, penalty is 1. Here penalty is also 1. P3 dash, penalty is 1. Penalty is 0. Penalty is 1. Now there is a tie. So what we do? We can send minimum number. We can take any one of them, but where we can send maximum number of items, or the transportation cost is, or we can say the cost is cost of per unit cell in that cell should be minimum. So let us choose arbitrary. We can choose this point. If we choose this point, 7 is minimum, 10 is the demand, 50 is supply, so we can send 10 items to this point. By sending 10 items, this cell is exhausted. We are left with 40 items. Now we will calculate P4. 1 is the penalty for this point, 2 is the penalty for this point, dash we can put dash, 0 is the penalty, 1 is the penalty. So 2 is the maximum. If 2 is maximum, so we can choose this. 6 is minimum, so we can send maximum number of items to this station, and 50 is the demand, 40 is supply, so we can send 40 items. By sending 40 items, this row is over, so we left with 10 items. Now we have only 2 stations, so there is no choice, so we can send 10 items to this point. We left with 50 items, and then send 50 items to this point. So now the transportation problem is complete. Now we will, the number of allocation 1, 2, 3, 4, 5, 6. Number of rows are 3, number of columns are 4, m plus n minus 1 equal to 6. So this gives us the basic feasible solution. So this is a non-degenerated problem. So we get, now we calculate the transportation cost. Now transportation cost is 20 into 4 plus 20 into 6 plus 10 into 6 plus 7 into 50 plus 10 into 7 plus 40 into 6. So we get 80 plus 120 plus 60 plus 350 plus 70 plus 240. So 200, 260, 560, 610, 680, 880, 920. So we get rupees 920. So by calculating this same problem with northwest corner method, we get the cost, transportation cost is rupee 980. By calculating with least cost method, we get the transportation cost is rupee 960. So by using Vogel's approximation method, what we observe, the transportation cost reduced to rupees 920. So this gives us the minimum transportation cost as compared to northwest corner method and least cost method. Now I will give you one question. You will try to solve this transportation problem by Vogel's approximation method. This is station number 1, 2, 3. 1, 2, 3, 4 are the destination point. Cost associated is 10, 2, 20, 11, 12, 7, 9, 20, 4, 14, 16, 18. Supply 15, 25, 10. Demand 5, 15, 15, 15. So you try to find the solution of this transportation problem by Vogel's approximation method. We will discuss next topic in next video lecture. Thank you. Have a nice day.